that in Canada and Europe, the big truck is having a storage device equivalent to that of a trunk box. That's what you carry it in a travel box. Such a level they have brought down for a big truck. So, in all the advanced countries are giving attention to the energy storage devices, and we have a lot of literature with this going from lithium-ion batteries, whether the lithium-ion battery production and lithium-ion batteries efficiency. I call it efficiency and effectiveness and how durable. At the same time, you have to look at the reliability point also. Reliable for the application where we are choosing. Not only automotives and also your mobile devices as well as homemade devices, home application devices. These batteries, energy storage devices are very much essential. And I feel that many of the education institutions are giving attention how to develop the advanced batteries and how to go in for that. And meanwhile, many startup companies also have come up to manufacture batteries. The biggest problem, what I could see, is the lithium-ion batteries, the availability of rare earth elements, lithium, and other strategic materials for the production in large numbers. 60% of lithium I was sold, 65% of lithium I was sold is coming from China. And China is holding the major control over this material. These are the background with which we thought we will throw some light, enlighten our IE members, and some of the students also are participating in this particular talk, as well as some of the specialists also they are participating to hear from Dr. Ilangovan. And he has about his background and biodata, our secretary will read. And he has a very rich experience in the chemical and the energy storage devices, especially the materials. Materials are the area also he has a rich experience. And his contribution towards satellite launch vehicle and spacecraft is immense contribution. That's why he has been put in the number 2 position in Deputy Director of Vikram Sarabhai Space Center. So he has been. So we have requested him to give a talk on this. He is kind enough to accept our invitation and to give the talk. And now I request our Uday Kumar to give about his brief biodata and proceed with the lecture. Over to Uday.
Thank you, sir. Good evening to all. It gives me immense pleasure to introduce our today's chief guest, Dr.S.A. Ilangovan, Deputy Director, Propellants, Polymers, Chemicals and Materials Entity, ISRO, Thiruvananthapuram. Dr.S.A. Ilangovan graduated in chemistry at University of Madras during the tenure of 1980-85. He completed his PhD in the specialization of battery electrochemistry at Indian Institute of Science, Bangalore in the year 1992. His specific achievements in ISRO from 1993, that is from space applications, design, development, qualification and supply of sealed nickel cadmium and nickel hydrogen systems, advanced lithium cells, supercapacitors and supercapacitor for launch vehicles and spacecraft applications, polyurethane foam insulation and polyamide propellant feed lines for liquid H2 and liquid O2 cryostages, thermal production systems for space applications, propellant production, development of polymers, solid propellant systems, high temperature ceramics, demonstration of electric vehicles using battery supercapacitor plus solar. His area of interest are nanoscience and technology for materials and energy system areas, attaining self-reliance in energy needs of the nation, that is of electric vehicles. He had a credit of 60 technical publications and 2 patents. He involved in various technical committees at ISRO, CSIR, MEITY, MNRE, DRDO, CMET. He had several technical presentations in national and international conferences. He has a membership in MRSI, SSI, SPSI, AESI, Electrochemical Society, ISC, etc. His awards and honors: Astronautical Society of India Gold Medal for the year 2005 was awarded for meritorious contribution to space technology development. Also has been awarded for INSAT 4CR Team Award, Isro, in the year 2007. So with this small introduction, I'm happy to invite Dr.S.A.ILANGOVAN sir to deliver his technical lecture on the topic of sustainable energy storage devices, electrical utilities. Welcome, sir.
Yeah. A very good evening to one and all, and thank you so much, Dr. Uday Kumar sir, for giving a very profuse introduction about me, and very kind of you. So at the outset, let me thank our senior guru and our former Chief General Manager of our Liquid Propulsion System Center, our Thiruvananthapuram sir, respected Thiruvananthapuram sir, esteemed engineers of the Institution of Engineers, Madurai chapter. It is a happy occasion, and Professor sir was telling me that I kindly consented. I may take it the other way, like it was a great opportunity for me to talk to the number of engineers, that too from our own soil, from Madurai chapter. So it's sir, it was a nice introduction about the electric vehicle and electric mobility itself. As if you have seen my presentation, you have nicely summarized into my introduction portion is very easily has come out, sir. So that is the advantage. So let me go over to the presentation, sir.
Yes, please.
Is it visible, sir? The video, audio, and presentation?
Yeah, visible.
So let me start at the outset, because energy storage devices play a great role. And when it comes to electric mobility, especially for our electric vehicles and mobile units, because now millions and crores of mobile units are there. For these two, we'll have to have an energy somewhere else, and we'll have to get the energy storage system so that it is able to supply, especially the electricity portion. So the vast application comes for the mobiles as well as the electric vehicles. So that shows the importance of energy storage devices, especially our battery-based systems. So this is our main building where our Professor Sarabhai is continuously looking at us from VSSC. This is the main building. So Thiruvananthapuram sir was so familiar, and he was there more than about 4 to 5 decades. He is very familiar. So let me at the outset start with fond tributes to my guru, who was my PhD guide, and more than about 5 to 6 years. He has been a mentor, teacher, and though it is about 30 years, there is no single day passes without remembering him. So that was the guide. So it was a fatherly approach he was having, and he was mentoring us like anything. So that is the reason why we are all staying back in the country. Otherwise, people will fly off. So with the salutations to him, let me go over to the topics. Sir, how long I can take?
Leg work. You can take 40 to 45 minutes.
Okay, sir. Okay, thank you, sir. I'll try to within that. So as an overview, I'll start with an energy and the need for storage. And when we are going renewable, how we will be able to get the 24-hour availability and that to efficiency aspects. And then I'm going to today talk about another system called supercapacitor, that this combination of battery plus a supercapacitor. So the new systems, how these new systems are essential, or how they are going to help us in sustaining the energy storage devices for the electric vehicle. What are the advantages of this new system over and above the battery, and what is the need for that, and where the technology gaps are there, and whether the technology development, whatever is available, is sufficient for India, especially whether the indigenization is important, or when we continue to import, whether we will be able to make it available on an affordability basis to all our Indians. Because as the cartoons are showing, the cost of the vehicle, even the thief, when he is taking the vehicle without a battery, it becomes unuseful for him. So next time when he is going to steal the vehicle only with battery, he will take. That is what it shows. So our electric cars are really green or not is yet another point which we will have to answer. And whether it will be feasible, I will just see in another 45 minutes, sir. Wherever you have doubt, either you may stop in between or you may ask me in the end. I am ready to answer all the questions. Coming to this one, sir, energy, human beings started the energy consumption from fire, especially for safety purpose, as well as for heating, as well as, okay, that's how the man sixth sense was using it and started using the energy from firewood. Then a group of people, because how I am trying to say is that how the energy requirement becomes so high and what are the issues out of that, I am trying to see in the introduction. Point I'll take from this. Yeah, so when group of people joined together, then they started using the energy. Then we started employing the animals like horse or cows or ox like that for our taking the requirements to meet the human beings. That was equivalent to 1 horse was equivalent to 21 men. Then that was not sufficient. Then we got into the industrialization. Equipments came in. So tractors, trucks, lorries, then aeroplanes are all coming. So they go beyond about 4,000 men capacity. Horsepower, what we call is some 50 watts, what we are calling, all these bases are there. But unfortunately, all these things, like when we were using all these things, the fuel was up to animals, there was no issue. Once we started introducing the vehicle-based systems, then the requirements went up. Then automatically all the fuels that we were employing was carbon-based. So that was resulting, or that has been resulting for over the last one decade or 2 decades. If you look at it, it has resulted in a lot of air pollution, global warming because of the carbon dioxide that is coming out, and environmental destruction, and also economic dependence because the individual countries are having the kind of non-availability. So all these things have led to some kind of a controversies, that is global warming as well as deforestation, plus economy aspect were coming into picture. So with that, when we see now that the energy need for the next century, if you look at it, it is without energy, the transportation, electricity available, communication, manufacturing, agriculture, whatnot, everything, if the gamut of spectrum is very wide where the energy requirement is so high. But unfortunately, the 20th century was founded on wealth creation through fossil fuels. That is, fossil fuels are nothing but coal-based systems. But if you just look at the distribution of energy consumption over the world, it is the transportation and industry and residential requirements. And now that to add on the gadgets as well as the mobile phones have also added to that. The growing demand is there. If you look at the bottom curve, the up to maybe 1950, the requirements were very less. But from 1950 to now, even 2000, it has gone up. And in the last 20 years, it has also gone up further. Now we are nearly about the population-wise, it is about 700 billion. And presently, it is like that. In 2050, we are expected to go to nearly about 980 billion. But all these things are requiring energy. And the energy, any energy consumption or generation is based on the coal. Means if it is going to be like that, tons and tons, that is gigatons, billions of tons of carbon dioxide will be required in the future to come. So now it is very difficult. One thing is that the coal is dwindling. Another thing is that it has got a negative effect of producing the carbon dioxide. And transportation and industrialization, it is nearly about 60 to 65%. It is mainly based on coal. Now that it is time that we have to switch over. If we don't switch over, this is what is the condition that is going to be. Because the countries, if you look at it, different countries like USA or China, the manpower as well as not manpower, the population as well as industrialization, that is without any kind of control. Without control, it has gone up. Now, all of them has resulted in the increase of carbon dioxide, mainly nearly about 82% of the energy, the leading to 82% of carbon dioxide production. So these are all the effect that we are facing present generation. If it is allowed, it is going to be catastrophe for our future. So it is a very great requirement that the left side of carbon dioxide is going to become the right side of carbon dioxide, where completely one is that the carbon dioxide should be consumed by the trees. So we will have to make the forestation, as well as we should not permit the carbon dioxide generation. These are the two goals which are ahead of us. So if that is so, how we are going to meet the shortage of energy? If you look at it, the alternative is only lying in the nature. It should be environment friendly and it should be sustainable nature. And definitely it goes without saying that it should be efficient enough that the cost effectiveness is always there, that and everybody is able to effectively utilize the mankind growth is taking place. If we start from the left, which I was showing, the energy requirement as well as the population is definitely both are to be controlled. Means, see, if you look at it on the right side top, if you see the solar energy which is in the yellow color, it is about nearly 23,000. The terawatts are coming up. Actually, we are now in the megawatt and gigawatt level we are using, but another 1,000 times of energy is actually irradiated, and the what is impinging or incidentally what is falling onto the earth at a second instant of time is about 23,000 terawatt. And if you look at the other small things, no, even the coal will not be able to. It is only in the scale. It is about 900, and here the atomic materials, the uranium or kind of things are on the order of 300. Only we will be able to. Natural gas, everything is small enough that they cannot compete with the God-given or continuously available solar. If we are able to convert the solar energy in a meaningful way without evolving carbon dioxide, definitely the solution lies in that. So we will be able to meet the dwindling nature of the fossil fuels, and we will be able to control the carbon dioxide emission, which is as carbon footprint, and also definitely the global warming, ocean acidity, rise in sea level, deforestation. All these things we will be in a position to control. But unfortunately, whenever we are awake, this curve shows that in the daytime, the night 12 o'clock till our morning 6 o'clock onwards, if you look at it, no, our electricity requirement is coming in the form of blue curve as well as the red one. At the same time, the sunlight is starting around somewhere around 7 to 8 only we will be getting meaningful energy. So whenever the requirement in the daytime is going down, automatically the availability of energy is more. But whenever the requirement of the energy is there, automatically sunlight is not available to us. So what is the way out? If you look at the next one, if you see the curve under the yellow thing, whenever we are not utilizing it, if we are able to store it in a storage medium, automatically in the the light portion or sun the availability of is not there, means automatically we will be able to utilize it. That is the basic logic in that. But we have several methodologies of storing the sun energy. Automatically it starts from we know the several energy storage techniques are there, like pumped hydro, thermal energy, compressed air, and definitely electrochemical methods where I am going to concentrate today. And there are some other chemical also is there, methodologies are there. And mechanically flywheels kind of things, that is when energy is there, we will rotate the wheel and then it will get the kinetic energy will be the solar energy will be converted into kinetic energy. That kinetic energy can be utilized whenever the solar energy is not available, and the magnetic way also we can store it. But there are problems in storing using all these techniques, because if you look at it, one is that the capacity wise, the hydropower and all, we cannot use it in our watts level or some hundreds of watts level. We will not be able to use it. See, when we are on mobile now, especially the like mobile or laptop or electric vehicles or tools, all these things, when we are we have to take the energy on mobility, and wherever the transmission is not possible, we will have to store the energy and take it. And smaller powers like mobile or laptop cannot be used from our compressed air or pumped up storage energy. So automatically the electricity based energy, wherever the mobility is there, electricity based energy is the one which is versatile in form. So that is the way we are looking at it. So especially for the mobility purposes, electric utilities becomes the very versatile one. So if see in a mobile, can I carry a kind of compressed air compressor, or the pumped hydro energy cannot be carried. So they are all for stationary purposes, it is good. But we'll have to draw the line. Again, when it comes to battery or our electric vehicle, it is not possible. So definitely a storage system is supposed to, it is actually an intermediate step between the generation, energy generation, and its application, correct? So that is the way energy storage system is behaving. So when it comes to especially the renewable energy, only intermittently it will be available, whether it is wind energy, whether it is solar energy, all of them, day and night seasonal requirements are there, monsoon, climatic conditions will be affecting it. So supply to meet the round the clock requirements and peaking demands, the energy storage system should play a key role in continuous supply, one aspect. And another thing is that the efficiency should be very good in converting the energy into some other form and supply it at a different rate, especially higher rate it should be able to supply. So the energy storage system should be cost effective, as well as cyclic mode it should operate, because as and when the energy is available, it should be storing it, and then it should be delivering it. It becomes a cycle. So there should be no irreversible changes that are taking place in the energy storage system, which will bring down the efficiency. So the reliability is definitely going without saying anything. And methodologies are available, as I was telling, mechanical is there, thermal, electrical, chemical are there, and hybrid also can be used. But that means so the unavoidable nature, or it is inevitable to avoid the energy storage. We have to store the energy. So that means these are all the kind of chains. When there is an energy storage medium, it should be able to take it in a certain meaningful ways, accept and convert, and then store it. And it should be able to deliver at the point wherever it is required. So at the tap of a switch, if it is operating, then it becomes electricity becomes the easiest way to make it versatile enough. But when it comes to future, the problems are not over with this itself. In future, our requirements are going to be high, population is going to go up. So that means we should also see that the energy system or storage systems, making the gadgets and selling it itself is not sufficient. We should also give it to individual houses. Now there are efforts that are going on that the solar panels are installed in every houses. There we are able to pump it to the grid also. So wherever excess is there, everybody can generate, everybody can feed it to the energy grid, then everybody can acquire also. So that means in future, it is going to be a kind of a, everybody, each consumer will also be a stakeholder. See, these are all the things means how we are going to meet the requirements means. So as I was pointing out, electricity is the versatile form of utilization energy. So if this is the case, as I was also again telling, how we are going to start. So India, when it comes to the wastages or the theft, all the things are to be controlled. That is number one point. So how we will be making our own technologies to see that the wastage is not coming down, as well as we are making it cost affordable. Yeah, and another thing is that we are making a better living. Technology should be innovative enough so that the climate changes world over is controlled. So the sourcing the energy, storing the energy, and supply portion. These three S becomes now the buzzword for our energy storage requirements. And also when we come now, today's my importance is that in electric mobility, by going to electric form, are we going to achieve better than what the IC engine, that is internal combustion engine, is doing it? Definitely it is going to be better, because the amount of energy what we are using in IC is about only maximum 30% or 25 to 30%. At the same time, when we use electricity based, that is electricity storage based, either it is in the fuel cell or a battery or a supercapacitor, the electric motor wise, the traction motor is much efficient, and it is nearly about 80% or 70% we will be able to convert in a form, and also it will be more efficient, it will be silent and carbon dioxide free. That kind of the kind of ignition or knocking aspects will not be there. And the deficiency portion is that the cost presently is very high. That is what is the present problem. How we are going to reduce the cost, how we are going to make the technology is some of my thinking process. And I know the variety of people from mechanical side or electrical side and the chemical side, civil engineering people, all will be there. So if I am going to little more chemistry, please don't worry. That is not going to affect your understanding. As I was telling, the country is taking up new initiatives like a 15-year roadmap we have put up from 16 onwards 2030. India will save nearly about 60 billion in energy cost by about 2030. That is what is the proposal. And each 1 gigaton, that is, we are talking about this much 35 to 40 gigaton of carbon emission is taking place every time. And 1 gigaton is reducing by about 37% drop in carbon dioxide generation. So by going this way, electricity based, mobility based, we will be in a position to save the energy by of the order of about 60% in 2030. At the same time, bring down the carbon dioxide emission also. So these are all the kind of numbers which I want to show you. So if you see the right bottom curves, the other pollutant gases, whatever is coming, if you use diesel, this is what the number is going to be. And if I use electric-based utilities, this is what the number. The saving wise, if you see, nearly if the particulates are going to be about 90% and more will be less, hydrocarbon will be less, and carbon monoxide will be less. All these gases are the main responsibility for this, our increasing the temperature, that is global warming, as well as sea level rising and deforestation because of the sea level rising, and usage of wood also will come down. We have a very good advantage by going to electric utility. So the cost wise, if I look at it, this is a table which is making a lot of alarm bells for us. If you look at it, some of the red curves I have put now, the cost wise, the Volvo bus now it is 88 lakhs, and Tata non-AC it is about 33 lakhs, and the next one it is 30 lakhs. Next one it goes to about 1.2 crores, 2 crores, 3 crores. Electric bus and all, it is going to be of this 2 to 3 crores level. But the range wise, if you look at it, no, nearly this is about 400, 500 or something, this kind of kilometers only, and charging time is also going to be long enough. So that way, if you look at it, the cost is very, very high. How we are going to bring down the cost is the main problem. And even if you are bringing down the cost, whether the present system are going to be versatile or reliable, or do we have the affordability for doing such thing? Like we have hydrogen fuel cell, battery electric vehicle, hybrid also we can have, biofuels. So either we produce, or there is no doubt that the global warming is likely to perish the humankind. So if that is the case, if I just look at the components which are associated with the electric vehicles, no, it starts from a motor, and then the electronics. Without electronics, the motor cannot be controlled, and there should be a charger, and DC-DC converter is required. Some of the instruments and the switches are required. Safety equipments are required. But if you see the triangle, no, the cost of the battery staying at the top. So the 50% of the cost goes for the remaining aspects, but 50% of the remaining cost is actually consumed by the battery, and the weight wise also it is heavy enough now. So these are the points which we'll have to address. So now this comes the comparison. What is the power density, the rate at which it will be able to deliver, which for any storage system that is a requirement, and what is the quantity of energy it is able to store it in it. So if I look at it, the capacitors where the energy is less, the rate is possible. But the capacitors, when as the energy density goes up, no, the power density comes. Its ability to drive or deliver, meet the requirements. Suppose if I'm going in a vehicle, no, the battery, if I don't have the peak energy supply, I will be going in only 30 kilometer, 20 kilometer per hour speed. But capacitor, if I use it, if it will go in 60 kilometer or 80 kilometer speed, but it will come for only minutes. So this is how, like in Tamil, we used to say, no, so power is there, energy is not there. If energy is there, power is not there. So this is what is the problem with the present energy storage systems. So these are all the number of numbers which I am trying to say. So if we look at the hydro or air, the megawatt level we will be able to get, but only thing the small nature or miniaturization is not possible. But the flywheels we can do, so we will not be able to. So battery is somehow it is able to come to this level of 200 megawatt hour level also we can go, but the energy per unit area is little less. So let me start with the battery of lithium ion rechargeable battery, which has created a revolution when compared to our lead acid battery or nickel cadmium or any such batteries where 20 to 30 watt-hour per kilogram was there. With the lithium ion presently we are able to touch about 150, and there is a scope for us to improve upon further to the level of about 250 and further 500. So this is how this is there. But whether it is the increasing the energy efficiency alone will be able to meet our requirement or not is the point. So these are all some of the, like the chemical engineers will not be satisfied if I don't show the equations. So this is how the internal arrangements are there. Charge discharge curves are there. There will be an electron. Once one of the electrodes will be consuming the electron. Another electron, the electron will be delivering the electron. That's how the electron balance will take place in any battery. The opposite, when we are charging, the current flow will be in opposite direction. So I will not go beyond that one with respect to battery operation. So let me come to how the battery is made. So battery is not kind of a big thing. So it is all some set of powders which we start with, whether it is anode material or cathode material. There are some binder materials are used, and then copper, aluminum kind of materials are used. Otherwise, some of the salt materials are there dissolved in the solvent to form the electrolyte. So anode, cathode, and electrolyte, these are the essential items that are to be. The aluminum or any other stainless steel materials form the cell case. So the main thing which is taking part in the active charge discharge reactions are, these are some few about 5 or 6 powder materials which are very essential to meet the cycle life as well as deliver the energy per unit volume as well as unit weight. So that's how normally we call this as particles to battery. These are the few particles which are very important to make the active charge discharge and long life, cost, energy level like that. So now that the basic technology is available, we making how to make the positive electrode, negative electrode, slurry processing kind of things, coating onto copper or aluminum coat, we are making the battery. But with that, are we in a position to meet all these requirements of power, reducing the cost, availability of technology for us? How we are going to distribute for our nearly about 130 million or 130 crore of people? We'll have to supply this energy as well as mobile phones or electric vehicles for transportation with respect to bus, truck, or nowadays we are also talking about electrification of the aeroplane as well as the ship. So are we in a position that with the available technology, is it possible to completely meet the shortage? That's what I am trying to now address today. So these are all our capabilities that we have achieved. The capability for technology is there, but making it more and more engineering oriented and cost effectiveness, whether raw material is available completely with us, are we in a position to make manufacturing units within the country? When we come to that, not only within the country, anywhere else also, even the Tesla car, whatever we are taking, no, in our Indian market, it is going to nearly 80 or 90 lakhs and crores level only it is going. But if you are depending on an import technology, will we be in a position to meet that requirement? And what are the means and ways? So now when I look at now, I will have to have the comparison between the ICE, internal combustion engine, what is the energy available and what is the power. Then I will understand where is the gap and how we are going to meet that gap. So if I look at it, the IC engine is about 2,500 watt per kilogram. Continuously, as long as we are continuously supplying the fuel, it will be generating the power. But no way the energy systems are near to meet this requirement. So we'll have to increase the battery power up, or the capacitor energy should come to this level. Is it possible with the existing technology, or even in future, whatever we are proposing, we are in a position to meet that requirement to in a cost effective way? If I look at it, it becomes a little jittery. So how we will be actually looking at and how the whole world is going, I'll just show. So these are all even in the lithium battery itself. If you look at it, no, lithium polymer is the one which is giving energy density of the order of about 200, power density of about 5 times it will be able to deliver, and number of cycles about only 1000 it will be able to. So that means by power, this is only giving about 1000 watt, but the internal combustion engine needs nearly about 2500 watt per kilogram. So this is the crux that we'll have to, jinx we will have to solve so that we are in a position to meet it. So if I increase the energy alone, see now presently the lithium ion is somewhere around 300, that is 250 is there, I can still stretch, and the lithium polymer from about 250, I can still stretch it to, and lithium metal, I can take it to nearly 500 watt per kilogram. But even then, the energy is there, the power requirement is not there. There are promising materials which show about even 5 volt batteries we can bring out, like our cobalt phosphate or a different kind of materials, and silicon based raw materials for anode, still it will be able to provide better energy. But whether better energy alone is sufficient, when I look at it, yes. So we will be able to make energy density available. But what about the power density? If you look at the power density, the batteries are still lacking. The energy density goes, but not the power. Because when I look at it chemically, what is the problem with the battery? Is it slow? Yes, it is slow. That is what is. If I look at the kinetics, no, when this is the micro arrangement in the battery. There will be the binder. There will be a kind of conducting materials like carbon. The ions are to move, that like even in that 200 micron thickness, whatever we are using it as a coating material in the electrode, it has to travel a long way. Each electron or charge, it should travel a long way, that suddenly we will not be able to increase the power. So that power increase, if I do, what will happen? See, just look at it. See, now if I am drawing a battery over 10 hours, I will get this much capacity of 10 hours. I see, you can see the voltage, and then the time wise also about 10 hours it will be able to give. Just I increase it to maybe about 5 times. If I am increasing it now, automatically the 10 will become here. But you see, this much energy will be lost in that discharge time. So if we go to 2C, definitely I will be able to sustain it for only about 20 to 30 minutes. So this is the problem when I increase the rate at which the power, if I increase, the energy that is there associated, or it is what is stored inside, is not fully coming out. So the efficiency of delivery, the supply comes down. Then another issue is that, see, India is a country where we start from nearly about 30 degrees there, 40 degrees there, and north if you go, it is 5 degrees, 0 degree level it will go. So temperature dependence also is there. So if you see the energy or the area under the curve, if you look at it, there is nearly only half of the energy only will be available. These are all the issues where we are finding it difficult. And then even if you are charging at a higher rate, also the efficiency will come out. So what I'm saying is that energy density, I may be able to increase, but there will be efficiency problems. And these problems are directly having a bearing. Why means, see, there is an open circuit voltage. There is a resistance associated with the battery when we are discharging at a higher rate. If the rate goes up, the resistance, what is felt is also increased because it is I times. All of us will understand that the I times it goes up. This is the one which causes, like when I'm doing it at a higher rate, the voltage is coming down because the I times the resistance, it will go up. That's how I into R will become the voltage portion. I square R will also be adding to the another parameter. So this is the one which causes the internal heating. Energy efficiency comes down. The life cycle comes down. The cost per unit energy, that is our kilowatt hour wise, when you look at it, it goes up when I'm doing it in the peak current. But any application when I see without peak current, I will not be in a position to use it. So these are all the issues when I was citing out. So when I see the actual electric vehicle, this is the way the power requirement is there. So the red is the one during acceleration. No? The blue curve is when we are doing it in the normal mode, gear changes only. But when I'm accelerating now, the power rating goes to a level of nearly 3 or 4 times. It is always the peak power requirement. So these are all the peaks which are going to cause the problem in the battery during our operation. That's how the cycle life comes down in the battery. So what are we going to do? Suppose if I connect a capacitor, am I going to reduce the load for the battery? Definitely. This is what the typical curve which was worked out when there was the simulation was made. This is how the peak power will be reduced if I am bringing in a capacitor across the battery. So if how we are going to bring a capacitor in a battery, that's what we were trying to know. A new energy device was brought out. That energy was nothing but a supercapacitor. That supercapacitor is having all the power. Unfortunately, the power is there means automatically the energy loading in that is very poor because it is only on the interface it is getting stored. If you look at what is the battery, what is the supercapacitor comparison wise, if you look at it, both are in electrical form, both are having a kind of simultaneous reaction, but in battery it will be an oxidation and reduction reaction. In supercapacitor, no such reaction will be there, so the energy portion will be less. And since it is interfacial, there is no long pathway for the electron to travel, so it will be able to give the energy faster. So that way, if you look at it, as the Ragon plot was showing, energy density is high, power density is low, and energy density is low here and power density is high here. So something like that. If I use the ultra capacitor now, like a tortoise, it will go fast for short duration and it will take a rest. But the battery will be going in the speed of a tortoise only. It will be rabbit in the ultra capacitor capability, and in battery it will go for long duration, but it will be only slowly go. So this is the problem. How we are going to unite these two is the crux of the day today, that how we will be able to do it. Otherwise, supercapacitor for short duration applications, it is very good. It will be able to sustain a nice way of like pulses, like wherever, like when I'm having a drill gun, the pyro elements, So that means it has got a short duration capability. If something is able to charge it intermittently, that is the jinx that we would have solved it. So definitely we took up the, I'm not going to dwell in details. We took up the technology development. So starting from 500 farad up to down to 5 farad, we were able to do. We brought out the technology, and all these curves are inevitable because you don't need to understand it. I'm trying to say that these are all the nice ideal curves out of supercapacitor. This is the characteristics ideal supercapacitor can behave. So we could make it, and we have done tests for our aerospace applications. And one good thing is that if you look at it now, the peak power is able to beat even a small supercapacitor is able to deliver of the order of about nearly about 100 ampere current. So this is what is the peak power that we wanted. It is able to, if you see the voltage now, even from 32 volt, it is only coming down to 24 volt when I am drawing even the 100 ampere. So when we cycled it now, so not like batteries, it is 1000 cycles. We could touch nearly 7 lakh cycles. So even for 80% the energy it was able to maintain. So that means 20% variation. Normally it is our cutoff value, but 20% loss, nearly it is about 7 lakh cycle it is able to give. So even short circuit protection is there. So these are all our routine tests that we'll have to do. So because in aerospace, always it is 50% of the time is for development, and it is more than 50% of time. Our supervisors are knows very well that they were all guiding us how we should be doing the tests, how to develop things, and how to qualify the items. Qualifying the item takes much more time. So once we are qualifying for our aerospace, definitely the requirements for our terrestrial application will be easily met with. So this is the way that we were doing it. Even during short circuiting, the temperature was only going about 2 to 3 degrees. Supercapacitor for short duration pulses and long cycle life it is there. But the battery is having high energy, but not power capability. So that brings in the hurdle for the our processes of electric vehicle or electric train, whatever we are talking. So we could use it in our rocket. In the supercapacitor technology, it was using well, but that doesn't mean that the supercapacitor will be able to power any small vehicles. So, but in other countries, no, even the metros, for every kilometer, it is getting charged. Whether it is German, Hong Kong, Japan, all the people are using electric. The metro trains where each stop it will get charged. So now it is a good thing. So that means for our truck or lorry, we cannot do such thing. So what is it we are going to do? So significant reduction, mass and volume also will be there because of such arrangements. So other than this, the applications are going for many of our variety of things, starting from marines or submarines or railways. Everything we will be able to use this supercapacitor also in line with battery. So this is how we could come to a conclusion. Like this is a logarithmic curve on the left side and the logarithmic curve on the y-axis and x-axis side. If you look at it, battery, it will have a very kind of small, very high energy level, but power level will be less. But if you look at the electrochemical capacitor, the energy level is less, power level is high. Suppose if I am combining these two, say like energy high, slow kinetics, power high, energy low. If I am combining these two together, like power also will be high, energy also will be high. So this is what is the aspect that we understood from the development of both the items. So when I'll just show this example. If you see a battery, I was showing over 10 hours when I am discharging, this is the blue curve that is coming. If I am taking it to 7.5 ampere, that is 10 times of the rate, you see how much energy is coming down, and it is not even delivering the capacity of half of that one. So now when we brought the supercapacitor, which are in aluminum cases, the battery in the left side is in the red. So I am able to get the intermittent power of 7.5 continuous pulse I am able to get, as well as 0.75 ampere, that is the sustenance for charging the supercapacitor, as well as during high gear, top gear, I don't need a very high current. So this is the kind of energy that we could deliver, which is close to C/10 rate, that is about 10 hours. If a capacitor is there for intermittent peak requirement, and the battery sustains the ordinary stable requirement. So this is how we could get the confidence. The combination of technology helps in meeting the peak requirement as and when it is required. So this is what the transient power requirements are met by the capacitor, and the continuous charging of the battery, the supercapacitor, and maintaining the low level current battery is able to do. do it. So, and another advantage is that when we checked, like power is moderated. See, you just look at it without capacitor. This is what is the voltage drop that is taking place. These are all the blue curves. And with the capacitor, no, it is not even coming down to very low level. So that means battery is saved, capacitor is incrementally getting charged. So if I am able to have the battery plus supercapacitor through a DC-DC converter, we will have a very good power capability. And also there are other advantages, and which we also tried for our electromagnetic actuator. It was given, even a small capacitor was able to give about 20 ampere kind of thing. So we demonstrated it, and also we have now that we are trying to implement in our launch vehicles also. And to demonstrate what we did is that we also added a bank of supercapacitor in our small car. So inside who are sitting are there our Dr.S.A.ILANGOVAN, former chairman, and Dr. Kiran Kumar, who is before him, they were there. So with the supercapacitor and battery, and a solar panel is also sitting there in the top. With that, we were putting up one Maruti van, and you can see the peak currents have all been controlled, and the battery voltage as well as the hybrid voltage was very high. So this was the kind of very high confidence it was providing. So we also measured, as I was telling, no, this was the peak. Otherwise, so if you have the battery and the supercapacitor, the values taken care very much. So battery alone condition, lot of peaks are there. With the hybrid battery plus supercapacitor, you can just look at it. We are having a very green curve, which is not having any peak power issues. So this will solve the problem of the cost, or at least reduce the cost, and also the long cycle life you will be able to get it. So this is how we could gain the confidence. So now another aspect is that when I'm having such a supercapacitor in this one, see in when we are going up, we will be needing the peak currents, and when we are applying brake, there will be back EMF that will be coming up. Then back EMF, because supercapacitor can take the energy fast, it can store it also. To the extent of about 10 to 15%, we will be able to save the energy by recuperating it through back EMF and recharging the supercapacitor also. One is that the big peak demand is met with, battery is not facing the big demand. So now that we try to combine these two technology in a single device. So that was the crux that we have broken, and we have taken a patent also in this direction for the first time. So this is our new contribution. Like these two are the anode and the cathode, and supercapacitor side we have taken the cathode portion alone. We combined it with the battery on the half way. So that way we could increase. So this is how the supercapacitor and battery, supercap and battery. That's why we call it as a supercapacitor or supercabattery. And both energy as well as the power aspects are met with. Definitely it becomes safe, long cycle life is envisaged, and also the peak power aspect is met with. So definitely a battery and supercapacitor will be current peaks are reduced, that is voltage drop is reduced to the extent of nearly about 80%, and the cost reduction, as I was telling you, is there. And supercapacitor based and battery based supercapacitor, again we tested it, we are getting a very good advantage. Even 1 ampere hour cell, 1 Ah supercapacitor is able to deliver about 40 ampere peak, and still the cell voltage is beyond the well above the cutoff value. So this is how, if we start with 1 Ah battery, otherwise it will not go even for 2 ampere peak current. We are able to get pulse wise nearly about 200 or 2 second level we have done it. This is 200 millisecond level for our pyro, we have done it. For the 2 second also we have done up to even we are able to get a 70C and 40C rate. So comparison wise, now that the third device has come up, battery and supercapacitor and hybrid, that supercapacitor, when we look at it, we made the device, and in place of our silver zinc, what we are using capacitor is now there is a lot of weight saving is there, plus high power pulse is there. So if you see this curve, which is better than the supercapacitor as well as the battery level. So this is how it is. It becomes complementary. Supercapacitor energy is increased, battery power is increased when I'm making it in a single device, and I don't need to connect them in parallel kind of things where the voltage difference comes and issues are coming up. So this is how we have come up with a new system. As I was telling, we were doing all the charge, discharge, overcharge, cycling at different rates. And see, this is the 100 ampere pulse over 200 milliseconds we were doing it. The short circuit also, even the 3 Ah cell is able to deliver nearly about 400. That shows that the peak capabilities very well, and it is equivalent to self-discharge. All those things is much better when compared to the supercapacitor to lithium-ion level. It is able to, if you look at it here now, even this our one IH thing is able to meet nearly several pulses of 20 ampere pulses. We were able to demonstrate, and here this is the routine type. What I was showing there, like the peak, when I am increasing the current, the peak current coming down is well solved, and the temperature wise also at low temperature it is able to give a very good thing, and it is able to sustain overcharge as well as over discharge. This is the important factor which I am trying to tell you. 200 milliseconds it is able to give 60 times the capacity of the cell. Even for 2 seconds we have done up to 40 C it is able to deliver. And also you see in the continuously, this is the current pulse, adjacently it was given, and the battery is for 3 to 4 volt. We are able to get nearly 800 pulses without any recharge. Supercapacitor alone means it will be coming down within this time hours. With the supercapacitor, battery plus supercapacitor together, we are able to take it up to nearly 2.4 Ah level for a 2.5 Ah battery, the capacitor. So this is how we could bring out the jinx well. So now with that, what I am trying to say is that in the charge discharge curve also, if from 3 volt to like a battery, it is able to get charged and it is able to deliver also. Use the supercapacitor 3H we have made, and 2H also we have made. We are able to 2H we are getting nearly about 2.23. We are able to get much better than 3H level. So now what is that? What I was telling our management philosophy, no? The tortoise and rabbit, how they used to be in the first time. What should I do when there is a water or speed when it has to go? No, when there is a water, the rabbit cannot cross. The tortoise will easily cross. And when it comes down, no, when we combine them together, both of them are very happy now. So in the water, the rabbit is traveling onto the tortoise, and whenever in the land, no, the tortoise is sitting on the rabbit. So now that it becomes a win-win situation with the supercapacitor and the battery side. So this is how we could break the jinx. And now that how we have also kind this one, if you look at it, no, the high energy battery and the high power supercapacitor, when we are combining these two, automatically the power level of supercapacitor is attained, the energy level of battery is attained. Now that we are very close to the IC engine level, we are the gap which was there, no, we are able to bring down the gap like anything. So this is how the new solution has been arrived at. With that, yes, our the initiative from cycle to the 3-wheeler to 4-wheeler to car and long distance aspect, by increasing the energy density, by increasing the new materials capability, we will be able to do, and cost wise we will be able to bring down with the different systems that are coming up. And lithium, definitely it is going to be a problem for the future, means sodium ion system is coming up. Conceptually, if a battery and a supercapacitor, carbon-based supercapacitor, metal-based supercapacitor, or the battery-based supercapacitor, if I am able to combine, whatever be the type of battery, we will definitely be able to sustain. And increasing the energy will increase the capability, and the cost affordability will increase. So this is the story. I think we have come out with new devices, and we are also working on the hydrogen cells, which are going to be the next generation beyond the batteries, wherein the water will be the product, where the gaseous hydrogen as well as oxygen which are going to be the reactants, and fuel cells. This is we are in a preliminary stage that we are going to come up. Once the battery things in the lithium ion kind of issues are coming up, by the time we will be ready with our fuel cell, wherein we will be able to supply. And again, the supercapacitor will form the parallel capacitor in between these one, means we will be able to meet. Otherwise, now hydrogen storage issues are there, hydrogen safety issues, which we are now trying to overcome. Maybe in another few years, we should be in a position. Variety of fuel cell systems are available. Proton exchange membrane, which is operating at 80 degrees, is the one which is more promising, and solid oxide fuel cell also is coming up well. And people are also looking at alkaline, but the concept is same. Hydrogen will be supplied. Oxygen will be either taken from the air, or we will be separately supplying. And yet another concept is now coming up, is the hydrogen economy is based on solar energy, and generate the hydrogen using the fuel cell in opposite way, and store the hydrogen and pump the hydrogen whenever we need it for the fuel cell operation, so that the total process becomes green in nature. And there are some kind of flow cells also for stationary purposes. We are using it. We are maybe that we are going to install also. It may not be used for space applications. For this one, it will be. So what I'm trying to say is that whether the energy storage giant in the energy systems of electrochemistry systems, whether we have overcome or not, when I look at it now, the battery is low kinetics and the rate will be a little slow, but advantage of increasing the energy possibility is still existing and we are doing and working on. But the capacitor portion is the one which will bring out the power, and hybridizing it with a battery will make it more and more complementary to each other. So supercapacitor is the device that will be actually going to improve the life, bring down the cost and maintain the better reliability as well as the kind of sustainability aspect that will be coming up from the supercapacitor based system in addition to our electrochemical systems. Definitely new materials like for the anode or cathode or ionic liquid based things will be a continuous process so that the safety issues are solved as well as our the energy availability per unit area or volume is coming up. But still the cost calculation, when we look at it now, the efficiency, cycle life and initial capital cost, wherein we are still not aware. See, this is the curve which I want to show you. The blue color thing, the blue color. See, this is the picture of our globe. If you look at it now, in America, some places are there for the blue colors are the one where the lithium ion cells are being made. Europe, it is being made, and Russia also. Here, there are countries which are making it. So now the China plus the other South Asian countries are making, but unfortunately in our India, we are not yet fully geared up to manufacture on a cost-effective basis with the indigenous systems. All are individually, like our Maruti car is having a separate unit, Honda car is having a separate unit, Toyota is having a separate unit. Because of that, the cost portion is still high. Unless otherwise we go for take a strategy wherein while maintaining the demands, the materials as well as the making the materials within the country and making the manufacturing within the country based on indigenous technology will be the thing. So definitely, like science and technology have to go means definitely our engineers are playing a great role in that to see that the science is put into technology and cost effective and reliable system is coming out. So we have a lot of activities. That's why maybe it is a right opportunity for me to give or look upon to the engineers to bring up the science as well as the technology portion for the application. So the renewable energy in a decentralized way, if we are making it automatically, it can be stored in battery plus electrochemical capacitors so that the sustenance aspect is coming up well. So now that it is hard to believe that just 200 years ago, our main energy was wood, and now that the energy sources is the range of energy, renewable energy based technology only we should be using, we should not be using the wood. And the future will be holding that definitely the population will go up, energy per capita per person per head, it will be definitely high. If that is so, definitely the other countries will be having their own norms of depriving the maybe the undeveloped countries or underdeveloped countries and the countries which are being developed. So it is how to bring down the cost means definitely sustaining the planet from the problems of pollution, or we have to definitely look upon the indigenous purposes. Then only we will be able to meet the future requirements of our the requirements. So import versus indigenization, if you look at it now, when there is a technology A, only they will be giving the technology E. And they are going to technology B, then they will be only giving the lower technology only. Definitely, if you are importing the technology, we will be definitely second or third only. We will not be touching the energy efficiency on our own. So now that indigenization is the main key. But when we are going for the indigenization now, filling the gap between the science and technology, allied materials, evolving the baseline technology, which is available only in pockets, that should reach to all the industries in a very cost-effective way and make in India. Every material and every metal should be made in India. So definitely we have the now technology available. Only thing, it should be cost-effectively, it should be made here, and that the government should be in a position to make the technology available to all the people so that the cost aspect is coming down. If that is so, definitely we can invite the multinational companies, and sustaining the technology and making it available to India becomes easy. And definitely a lot of people are doing research. So the ability to convert the data science to products lies in making the cost effective systems for the application. So definitely hugely it is the skill becomes important. The understanding the process, extracting the values, visualize, and where we should concentrate. Definitely some of the risks are to be taken, and we'll have to be like open-minded and communicate to the people. Our the R&D wing plus the institutions should come forward to take up the problems, research problems which can be affordable for the country, and they should not only concentrate on publishing papers and going abroad, they should also concentrate that the indigenous technologies are coming up and it is available for the country and the country is prospering. So this jinx of making the customer and academic gap always will be continuing. This should be brought down. Now that industry and academic, if you see in our country, definitely there is a big gap available. Whatever the academic people are publishing is not available to the country for making into small technologies. So this aspect has to be brought down. Once we are bringing it down, automatically the Make in India will be going up well, and the empowering and developing the employment, indigenizing thing will be actually go in a free flow manner. So automatically, so we are thinking that Isro plan of will leave some of the world countries surprised by bringing out more technologies and making the access to space also very, very low cost means automatically the more economy will be coming into, and we will also be bringing out countries. In summary, I think it is time that it is, I am summarizing it. The battery will take care of the high energy portion. Supercapacitor will take care of the high power. When I am combining it, the device into a single one, the supercapacitor becomes the combined form of energy as well as power, and thus be reducing the size, mass, and improves the run time as well as the battery life. And energy density, power density, the efforts will continue. If you are touching the 500 watt-hour per kilogram, automatically the power requirement of 2,200 or 2,500 the requirement will be easily met, and it will be supercapacitor will be acting as a big enough requirement, and secured energy storage and peak power will be there. And with the indigenization being there in place, and it will become the key for cost reduction as well as sustainability. And it is going to be the advanced materials which India which has to hamper, or it has to jump into that so that the energy storage becomes very efficient and the power is delivered for the future. With that, not only that we will be saving, and this kind of perils which still our villages more than several, that is 20 or the 20 up to 15 to 20% of villages are yet to get electricity, as well as people are studying with this kind of small lamps. So this kind of things also will be useful, and this kind of traffic snarlings and some of our imagination. No, still people are having this kind of bullock carts as well as cycle rickshaws are there. If battery can be made as an affordable thing, definitely we will be meeting the dream, as well as we will be helping the climate change for all over the world, not only in India. So now carbon dioxide, we will have to also increase the deforestation, not the deforestation, and wood-based requirements, which is evolving the carbon dioxide thing should be brought down. So these are all the greenhouse gases. So from the dry land, we should be able to make the oasis coming out of this one by consuming the carbon dioxide, and so that the water level also is taken care. Thus by, if you look at the India is not part of the red zones where the greenhouse gases are coming up. So other countries are doing it. At least with this technology, suppose if we are able to export, let us assume we'll also be helping it. So now that these are all the, see, like what is, when we are eating the fruits, it is always good to remember the people who have planted the trees. So these are all the people who were inventing these systems. And there were some other occasions also we were developing the supercapacitor in front of our Honorable Minister Nitin Gadkari. The Automated Research Association of India in Pune, they demonstrated the supercapacitor role in a Tata Ace vehicle, in a big vehicle. So these are all the actually systems which are inside the ARI. With the simple 25 ampere hour battery, we were able to run a big vehicle for about several kilometers. So the minister was very happy. And then that's what the madam from ARI is developing, and I am there, and our minister is witnessing it. So with that, I come to a conclusion. So let me, without giving the acknowledgement, my presentation would not have been completed. So I profusely thank the Institution of Engineers for giving me this opportunity especially when it comes to our mentor as well as guide and our senior Thiruvananthapuram sir. I am especially beholden to him for the guidance as well as when he was here the guidance, and now that he is giving us these opportunities to present it to you. So with that, the photograph shows that the people are all from India, the Indian scientists who are contributing to the battery. So thank you so much, and very best wishes in this corona condition, pandemic condition. Be safe and be at home. So now that with the salutations to our Guru, bigger Guru, our Abdul Kalam sir, dreams is not what you see in sleep, it is the thing which doesn't let you sleep. So with that, let me come to a conclusion, sir. Thank you so much. Sir, any questions on that? I am ready to answer, sir.
Sir, am I audible to you?
Yeah. Go ahead.
Hello, sir. Am I
Go-
audible? Hello?
Go ahead, sir.
Audible,
Go ahead,
sir, audible to me.
Yeah. So, you have cleanly explained the details of the supercapacitors with batteries, and the life of the battery is very less comparing to the life of the vehicle. Similarly, the life of the capacitor is much lesser than the life of the battery. And to compare,
Sir, actually, life of the battery is much less, but life of the supercapacitor is much longer. As I was telling, it is about 7 lakh cycles it was able to give. Battery will give only in thousands of cycles. So why it is giving thousands of cycles is that because of the peak power which we are drawing makes the material undergo irreversible changes, sir. So now in the supercapacitor, the life is very long.
okay, sir. Thank you, sir.
Thank you, sir. Thank you.
Rajabal, sir. Okay. Mute. He's mute. Rajabal, sir, is mute.
Any further questions are there, sir?
They what? Rajabal, sir, is in mute. I think he's asking some question.
Yes, sir. Yes, sir. I will ask him, sir.
Thiruvananthapuram, you can proceed.
Okay. It is a very good presentation, Dr. Ilangovan.
Thank you, sir.
It is we wanted you to enlighten us about the energy storage devices, which is either hydro or electric, or even you have touched upon flywheel. Flywheel, you know that we were making reaction wheels, and I think that is being used in most of the Japanese telephone exchange as a UPS they are using. As a UPS, the flywheels are being used. So you covered quite a lot of things. The second point is which I thought will be relevant for engineers' point of view, is a privatization. The technology which you have made, you have invented, or you have brought to application, that has to be commercialized. For which Isro is making some effort. Isro is making an effort for privatization of certain launch vehicle and spacecrafts. Whether Isro is making any effort for privatizing the technology, or something like IPR. There is one thing which you can think of and address. And second point is in India, you see the most of the knowledge or sources are separately. It is there. Even Sekari Karakudi director also says he has worked in hybrid fuel cells. You may be aware, Madam Kalachelli. So, whether is there any forum, any society or an association of amalgamating all the batteries, the energy storage devices, One minute, some election campaign is going on. Just a, so, whether is there any association which can amalgamate and bring all the energy storage devices to a single entity, so that the country will be benefited. That way you can think.
Shall I answer, sir?
Yeah, please go ahead.
Sir, with respect to technology transfer, nearly about 7 to 10 companies have taken our technology with respect to battery, lithium-ion battery, and they are maybe about 2 years back they have taken up, and they are all putting up the facility, and they are going to start the production of our space-based battery cell technology, and they will be converting it to our ground-based technology, sir, using the main things. That is number one. Supercapacitor technology is given to our Keltron, sir. Our Kannur Keltron is taking, they are putting up the facility for producing the supercapacitor for national requirement, as well as likely that if it is getting qualified, we will also be using it. Sir, is that clear?
Chairman, sir.
Sir,
Sir?
you can take over and deliver what of the.
Okay, sir. Sir, are you having any more questions from audience, sir? Okay. Rajamouli, sir, I will propose a vote of thanks, sir.
Yeah, definitely.
Yes, sir.
Sir, as you are, my answer was clear to you, sir. We have given the technology to 7-8 companies.
Yes, sir.
So they are planning, because about 2 years back we have given the technology. They are putting in the facility and coming up with respect to lithium-ion cells. And for the supercapacitor, our Keltron Kannur has already taken the technology, and they are going to produce for the country. And if it is once qualified for space, we will also be getting it from them, sir. Supercapacitor is yet to be transferred. If promising parties are coming up, then we will be doing it. And with respect to associations, sir, yes, we all have a kind of, whenever there is a conference, and then when we have an Electrochemical Society of India is there, as well as SAIST is there. Through the SAIST only, we all, I'm in close contact with Dr. Kalachelvi also, and I am also taking part in their institution reviews, and when they are also involved in our kind of reviews that much. So there is association, means it is a kind of informal association. Not the technical aspects are being discussed, but technology transfer things are taking place, sir.
You know, you are a member of Institute of Metals, IAM.
Yeah.
You are a life member of IAM. IAM is a large body, like Institute of Engineers. Institute of Engineers, we have 2.8 lakhs member engineers. Whereas the institution of IAM is having, I think, something like 50,000 metallurgists and scientists. IAM can have a small wing for energy storage thing and separate thing for special materials, something like that. If you have a branch of IAM for this battery and energy storage devices, that branch is a subgroup of IAM, I call it. Subgroup of IAM, that can be a much better approach, by which otherwise you will be one among the IAM member. Instead of that, you can the subgroup can concentrate on presenting the papers, patenting it, and bringing to the society and the common man. It will be of use. That's what I thought. That's why I asked the question.
Sir, that is a very good suggestion, sir. The knowledge percolation and spreading the availability of technology to all the bodies as well as the industry is a very essential thing. So that it is considered by the industrialists as well as information percolation takes place. So with respect to our electrochemistry society we are having, with respect to IEM, sir, I will also talk to the chapter people here and then we will see what best can be done.
High energy materials or something like that. Okay. That's it. Okay.
That is a good suggestion, sir. We'll try to pursue it.
With your permission, can you send your PowerPoint to our secretary so that it will be useful for others? I think it is not classified. Yeah, it is not classified.
Some of the graphs, all those things, I will try to keep it aside, sir. And the logic portion, conceptual thing, otherwise also it will be continuous. Continuity will be there, that I will forward it, sir.
Oh, sure. Very nice of you. Very good question.
Okay.
In fact, we want to have one more a convention, national convention, bringing what you said as Secretary, yourself, IIM, and High Energy Material Association, Anna. So with these people, we thought for the energy storage device, we thought we can have one convention. But already I was told somebody has taken a lead for having a convention of energy storage devices. If possible, we'll try to have a smaller level of convention. Please participate and contribute your thing in the proposed convention. Okay.
Fine, sir. Fine. That is a good suggestion, sir. All the bodies can come together so that sharing of knowledge takes place as well as technology is known to the other people, and it will be also good, like new ideas will crop up.
We can have a national convention, sir, on this topic.
Fine, sir. Fine. Correct.
நீங்க lead role எடுக்க முடியுமா? ISRO கொஞ்சம் ஸ்பான்சர் பண்ணி lead role எடுக்க முடியுமா? We can organize a national convention on this regard.
But sir, we can take, ISRO can take only when our space application related things. But the industrial things, if IEM can take, are our general bodies, sir. Other general bodies, which will also have the link with, like IEM type of thing, only they have the link with the industrialists.
Okay.
I can discuss with IEM chapter people here, sir.
Secretary, our CSA and RRL கேட்டு பாருங்க. I think Pai is there or still is retired. Dr. Pai in RRL.
Our Dr. TPD Rajan, he is the secretary, so I will get in touch with him, sir.
Oh, sure. Yeah, I think he's IAM president or something like that.
MRSA come IAM both. He is secretary.
Very good. I am also a life member of both the association.
Very good, sir. Very good. I'll get in touch with them and try to get some feedback, sir.
Good. Very nice of you. We had a very good session. இவ்வளவு பொட்டன்ஷியல் உங்கள்கிட்ட புதைஞ்சிருக்குங்கிறத இப்பதே நாங்க வெளியில பாக்குறப்ப தெரியுது. I think it should be, as you said, knowledge sharing. Knowledge sharing it is very much essential. Dynamic knowledge sharing. Because you are going on updating and your graph is going on exponentially போயிட்டு இருக்கு உங்க knowledge. அதே அளவுக்கு அதை நீங்க வெளியில கொண்டு வரணும். அந்த இதை எங்களால முடிஞ்ச அளவுக்கு we will try to help you. It is a good attempt and a very good lecture. We had a good session. So
thank you, sir. Thank you. We are trying, sir. We are trying to take it to industry because both supercapacitor and lithium ion we have already given it. So supercapacitor also maybe BHEL may be interested because they are planning to make the cells for us space applications, as well as they will be giving it to kind of electric vehicle requirements also. They are coming up. Qualification is in progress.
So, sir, in market, will there be any shortage due to the lithium availability? And we are developing other type of batteries from air and all those things under research. So how will be the future of these lithium batteries?
Yes, you rightly pointed out, sir. Lithium will have a problem because China and other countries have completely taken over the mines available in very few areas, and we have come across some about maybe 1 metric ton kind of not the about 10 power 6 tons of lithium is possible. We may be able to sustain for some period. The lithium aspect is going to be a problem. That's why the hydrogen oxygen fuel cell aspect is likely to come up. And sodium ion also is coming up, sir. With sodium ion supercap battery, we should be in a position to do it. Already Reliance has taken over a company called Paradigm from UK for energy storage applications for our India.
So
Sodium
what is your experience with the sodium ion batteries?
The sodium ion is coming up, so like the lithium ion only. Only thing, the materials based on sodium will not be kind of cripple for us. Lithium is going to be cripple because the lithium is mainly stored by the nickel and cobalt materials, which are also costly, and lithium is also costly. So the 3 elements are there in the lithium ion, which is costly, and reusability also is a little difficult. So recycling it for that matter. That when it comes to sodium, because sodium is plenty available, and sodium-based salts are also can be easily recycled, better recycled. So that way, cobalt-free and lithium-free battery cells are coming up. That is what is the one now that UK-based company has been bought by our Reliance. So that will be now coming up for India. So they are going in a big way, like now how the Adani group has gone. No? Now they are able to go for nearly 100-200 gigawatts level solar panel. So like that, the Reliance is also coming up with the solar as well as battery-based technology. So Reliance battery will be based on sodium ion. In maybe in a year or two, sodium ion batteries for energy storage is likely to come up in our country.
No, I was original doubt. Lithium, sodium, lithium will have a small percentage in grammar. I remember. Lithium, sodium combination, it will become
on the point, already a lot of results is coming, sir. But still, the lithium availability will still be problem only, sir. So that means if we are using it lithium sodium combination, whatever we are planning, we may get exhausted in 10 years, it will get exhausted in 20 years. So sodium based completely alone, sodium alone based system will be the one, but energy density will be little poor. By the time the idea is to come up with hydrogen storage materials, handling of the hydrogen safe way, and making the hydrogen and oxygen fuel cells, which is cost effective. There, the platinum catalyst is the one material which is the problem. So platinum-free catalytic materials are being developed, and we are also on the way, sir. Using the solar energy from water, generate hydrogen, use the hydrogen with the air, generate the power. Product will be water only.
The high energy storage material items, lithium is playing a major role. Your long range lithium free battery, as you said, hydrogen cell and hydrogen based things. But anyhow, for the other aluminum lithium alloys, essentially it is indispensable for as far as liquid engine tankage is concerned. Everybody is there using aluminum lithium, so lithium is going to remain. So we have to use it. Or stage la thorium mari eppadi
correct, sir. But for our launch vehicle community, we will not be using that much lithium, sir. We will, even if it is 20% lithium in aluminum, the requirement for our launch vehicle community will be maybe 1/100th or kind of thing only. 10 batteries.
Okay, good, nice.
So sodium based and hydrogen based cells are the one which are going to rule in the future, sir.
Okay. There is a roadmap. Roadmap for the high energy battery will be the sodium based or hydrogen based.
Hydrogen based, sir. But now there is one more new technology called aluminum air. So use the aluminum foil. As and when the aluminum foil is consumed, remove it and add the aluminum foil as a rechargeable, mechanical rechargeable. So aluminum sheets will be added into that. So that is also coming up well, sir. So because aluminum always we can After going to some 300, 400 kilometers, there can be another bunk where we will take the aluminum cartridges, add to that, and aluminum aerosol will go on. Sodium hydroxide and aluminum will be added immediately.
Related to the thing, a small or a note. Today I read in paper, Elon Musk for the going for Tesla car for electric vehicle. அவருக்கு எப்படி இந்த இனிஷியேட்டிவ் வந்ததுன்னு கேட்டீங்கன்னா எப்படி வந்ததுன்னு கேட்டீங்கன்னா he has narrated he lost his son due to explosion of lithium nickel battery. Lithium nickel battery explode ayi his son, he lost his son. So that was a driving force for him to make electric vehicle for the entire
using the same cells.
Yeah. They were நம்ம Dreamliner 777 aircraft exploded because of lithium ion batteries. That's why they have changed it over to the electrolyte out of powder, lithium sulfur. They have gone for this. Okay.
Correct. So that was misuse only. They did not have the overcharge protection. The Dreamliner issue was that overcharge protection was not there, so that's how it got overcharged. And then same Dreamliners that they are using for door opening, all those in supercapacitor.
Very good.
High power. So metal air batteries, hydrogen and sodium ion. These are the three things which are likely to come up in the future for electric vehicle applications. Sir.
Emerging technologies.
Because hydrogen filling is also will be fast, huh? And replacing the sodium also will be faster, rechargeability. And next is that battery swapping. Charged cells will be available, like Indian Oil bunk, any bunk we can go, take the battery and go. So they will be owning the battery, we will be renting it, giving the rent for them.
One small, finally, as a part of your talk, can you say to our headquarters that the future path is going to be carbon-free, lithium-free, sodium-ion batteries with supercar battery for the future electric vehicles? That's what the gist of your presentation.
Sir, you can give 1, 2, 3. The next system will be sodium-ion battery, followed by hydrogen plus aluminum ion.
Okay.
Because that energy density will go up over the sodium ion.
Very much. We can make us a gist of our recommendation. And
yeah, correct. We can make the gist
just for the talk and recommended for the future roadmap. We can mention in our think to headquarters. Okay. Thank you. Very nice presentation.
Sir, shall I propose vote of thanks, sir?
Yeah, please. Yes,
sir. So good evening to all. Again, it's a great privilege and honor to propose vote of thanks to our today's technical lecture meeting.